Hi everyone, welcome to Rakesh Sir Lectures. And today we are going to discuss about spectacle accommodation versus ocular accommodations. Right. So, as we have discussed the earlier classes about spectacle refractions and ocular refractions, so based on the concept, we continued to learn about spectacle accommodation and ocular accommodation. So the series of the outlines, what you need to study in this is, first we need to build a concept of what is spectacle accommodations, right? And then we have to build a concept of what is ocular accommodations. Then we spectacle accommodations, how it differ in emmetropia, myopia, and hypermetropia. Then again we are going to build a concept on ocular accommodation. This is very important. Ocular accommodation in context to Emetropia, Myopia, and hypermetropia. Okay, and then we are going to give some conclusion after learning all this story or after all this lecture. So we'll go. Let me define it. What is spectacle? What is spectacle accommodations? Anyone? What is spectacle accommodations? Yes, no. See, if you are wearing glasses, right? If you are wearing glasses, and if the measurement distance is taken from the spectacle plane, if this is your glasses, see, this is your eye, and this is retinal plane. So if you are wearing glasses, then of course the glass will be at some distance from your eye. So let's assume here is the glasses, right? For myopia, you are wearing glasses, and this is the glasses, right? And the distance between this is called as vertex distance. So the plane at which this glass is placed or held or kept, so this plane is known as a spectacle plane. And if you are measuring the distance, let's assume you are seeing distance object, right? So for distance object, what we are going to see is, if you are wearing glasses, the measurement should be taken from the spectacle plane to that distance, right? So vergence of light at this point is how much? Okay, so all, if the the amount of accommodation will be determined by Vd minus Vn, right? You just take the distance from this point, right, spectacle plane, to where you are seeing, right? If you are seeing for 40 centimeter, 50 centimeter, 1 meter, or you are seeing at infinity distance object, so based on what distance you are seeing, you just reciprocal do a reciprocal of it, you will get your accommodation. So spectacle accommodations at this spectacle plane, you have to do a spectacle accommodation. There is one formula for that, right? And this spectacle accommodation is equal to, don't forget it, Vd minus Vn, vergence of light when you are seeing for far, and vergence of light when you are seeing for near, at some near objects. Then what is the vergence difference, right? So that vergence difference is known as a spectacle accommodation. Same, this formula will apply for, it is a common formula, it's apply for a spectacle accommodation as well as ocular accommodations. So as we are discussing for a spectacle accommodation, is the only difference between both is we know this is a spectacle plane, right? So if the measurement is taken from a spectacle plane, then it should be called as a spectacle accommodation. And if the measurement will be taken from principal plane, from here, principal plane, then it should be called as, this is the principal plane. So if the measurement will take from this plane, then we should be called as ocular accommodations, right? So all the measurement, after doing measurement, we have to apply these calculations. So, and this will give your amount of accommodations what you are doing, right? Let me show you glasses, 1 minute. Yeah, this is my glass, uh, right? So if I'm wearing glasses, right, just see here, if I'm wearing glasses, so that means, see from lateral side, this is the glass plane where the glass is held, and this is my eye. Yeah, this is glass plane, spectacle plane, and this is eye. You can see you can feel the lateral bone here, right? This is lateral bone, what we are touching here, lateral side, this is lateral bone. So ideally when we are not wearing glasses, we tends to measure from lateral bone. When you are taking measurement, you are keeping a ruler or a scales at this point, right? So so that's the reason, that means that time we are measuring ocular accommodations. And when you are wearing glasses, I have myopia, and if I wear glasses, then this once I wear glass, I should be considered as emmetrop, and that means Emetropia starts from a glass plane. So ideally when we are doing measurement for the our feasibility purpose, or our sample purpose, we are not going to measure from it, because again this lens will restrict, right? If you can't place, once you are wearing glasses, it's very challenging to place ruler on the lateral bone. So what, for the convenient purpose, what we will place, this scale or ruler will place at the spectacle plane, and from there we are going to measure it. Are you getting it? Yeah, I hope you have got. So this is about a spectacle plane, but truly speaking, in clinicals, the vergence of light present at this ocular plane or principal plane, that will actually determine the amount of accommodation. The change in vergence, because from here the lens is there, crystalline lens, right? So the change in vergence at this point just before the lens determine what will be the accommodative status. Either they should do, or either they should relax. Just for the simpler purpose, I will tell you. Let's assume here is +10 when you are saying, just example, okay, just +5 diopter when you are seeing far. Ocular accommodation I am talking about. Just assume when you are seeing far, this accommodation is +5 diopter. But when you are seeing, just assume at 1 meter you are seeing, right? 1 meter you are seeing, and when you do calculation later in the lectures, we are going to discuss the calculation. So when you are seeing 1 meter, this version changes to +4 diopter. Now see here, vergence when you are seeing distance, Vd is +5, and vergence of light at this principal plane when you are seeing for near is +4. And that means what is the change? +1 diopter has decreased. +1 diopter has decreased when you are seeing near. +1 diopter has decreased in the sense it will be less convergence and light will focus behind the retina. That means there should be some mechanisms to compensate that, and light should get fall on the retina, right? Here when you are seeing at 1 meter, it is +5 diopter one, +4 diopter only, right? The +4 diopter means that extra 1 diopter is less. That means light will be less converged, so light will get focused behind the retina. That means we should have some mechanism to get back that light into the retina. Are you getting it? So this extra 1 + 1 diopter will accommodate by lens, or will be given by lens, and this is one is the change in both versions of light is known as how much accommodation is should do, right? For example, other example we'll take it. Let's assume +5 diopter is vergence at distance. You are +5 diopter hypro, and you are wearing glasses. So let's assume at this plane when we did calculation, +5 diopter vergence is there, right? And when you are seeing near at 40 centimeter, let's assume this this vergence of light at near, it becomes not now +4. Let's assume it becomes +2.5 diopter. This is VR. Now see this too. When you are seeing far, that time it is +5, and light is getting focused on the retina. That time when it is plus 5 Vergence, when you calculate the Vergence at this plane, it is, if it is plus 5, just examples I'm telling you, right? So if it is plus 5, it is getting focused on the retina. This is the assumptions. But same eye, if they want tends to see at 40 centimeter or to read a book or use a phone, that time the Vergence of light at this plane has changed to plus 2.5 diopter. That means plus 2.5 diopter has decreased the Vergence. That means that decrease in Vergence will made light, if the lens will not accommodate. If the lens will not accommodate, then this light will be diverse. That means it will less converge by 2.5 diopter. That means light would focus behind the retina in respective 2.5 diopter, right? If this lens would have not there. But nature has provided a great mechanisms to compensate this and get that back light into the retina. So lens will accommodate by 2.5 diopter, it will compensate this, and the light will be again conjugate with the retina, right? Am I right? Anyway, we are going to see in detail about this spectacle accommodations and ocular accommodation step by step. So we have built a concept of spectacle accommodations and we have built a concept of ocular accommodations, right? We are doing NPA, right? So to find out amplitude of accommodations, so just imagine if you are taking the measurement from a spectacle plane, it is called spectacle accommodations, and if you are taking from the corneal or lateral bone side, then it should be called as, because lateral bone, it is just more beyond this, it's approximately resembles the distance near to principal plane, because cornea is little front, lateral bone, this lateral bone, or we can call it this point, lateral point. So this is approximately near to principal plane. Okay, am I right? So now you see. So, but clinically, which is important? This spectacle accommodation never exists. It is just for our documentation purpose and if easy to measure. So we are taking just from the glasses. Once we are wearing glasses, but once you are not wearing glasses, you can easily measure from the this lateral bone, right? Lateral bone, lateral canthus, lateral bone and lateral canthus. So ocular accommodation is true, which determines change in their Vergence determine the change in accommodation. But spectacle accommodations, as they are very close, how much close? Yesterday we have discussed, this is the D will be approximately how much, if you keep near also, it will be approximately 12 to 13 mm, and this will be around 1.5 mm, right? So togetherly it is 1.5 centimeter or 15 mm, right? So what you understood from this? Even the distance is very small, 1.5 centimeter. But of course, in the when you are wearing glasses and if you have low power like 4 to 5, 6 up to 4 to 5 diopter, there will be no much changes in accommodation. If you take measure from this plane also and if you measure from this plane also, both remain same. And most of the refractive error will be either low or medium categories, right? But the problem will occurs, or the changes will occur between spectacle accommodations and ocular accommodations when you have high degree of myopia or hypermetropia. Like let's assume we have plus 10, because I will take again the examples of plus 10 diopter because it is easy for us to do the calculations, right? So remember, this is just for our convenience, spectacle accommodations. We are measuring from the spectacle plane, but this is the actual exists in the anatomy and physiology of the eye, right? Ocular accommodation is the real one which exists in the anatomy and physiology of the eye. Based on this parameter, ocular plane Vergence change, this accommodation will change. Lens will accommodate or relax. Okay, lens will accommodate or relax. Now you tell me. So we have completed, we have built a concept on spectacle accommodation and ocular accommodation. Let's see a spectacle accommodation in Emmetrop, and then we are going for myop and hypermetrop, right? So just I will erase this. So for Vergence, you just remember what is the common formula, VD minus EBN. Either spectacle accommodation or it is ocular accommodation, both remains, formula remain same. Now let me discuss about spectacle accommodations in Emmetrop, right? So spectacle accommodation. So I'll make three eye and I'll explain one by one, right? Look, just see here. Here one more. So this is our eye, and this both eye is for emmetropic eye. And emmetropic eye, what is there? See here. Let's assume this is the glass plane. I'll just making like this. This is the glass plane, and either you can imagine like they are wearing plano glass, plano power, as it is emmetropic eye, as it is emmetropic eye, emmetropic eye. As it is emmetropic eye, this is plano, or just you imagine this is a spectacle plane where it is 13 mm from the cornea. Now what we'll see here is the light coming from infinity. The light coming from infinity will pass as it is, and it will get conjugate with the retina, right? Parallel ray of light after striking the cornea and after refraction through the eye, it will focus on the retina. This is only Emmetrop, right? So if you take the Vergence at this point, a spectacle point, this is the spectacle plane, SP plane, spectacle plane. So what with the Vergence? Vergence of light is at this point is VD equal to, how will you find Vergence at this point? Light is coming from here. So what I told in the earlier lecture is once you have to find the Vergence of any point, so just do the reciprocal of the distance. So light is coming from infinity, so distance from this to infinity is infinity. So and reciprocal of infinity is 1 by infinity, you will get 0. So Vergence of light at this plane is 0 because there is no convergence and no divergence. It is still the parallel ray of light at this plane, right? So Vergence of light is 0. There is no convergence and no divergence. If the Vergence is negative, that means light is diverging. If the Vergence is positive, that means light is converging. Am I right? Yeah. So now you see the Vergence of light at this near. Let's this emmetropic eye focus at near object, right? So let me draw this. This is like focused as some light is here. The object is focused at near object and at 40 centimeter. So from here, what will happen? Divergence light will be emitting out. So this is 40 centimeter from this glasses, right? Are you getting it? So a spectacle accommodation now will be anyway, we are measuring from this plane, right? So from here to this distance, we need to know the Vergence at this point because we know the formula, right? I have to write formula somewhere. Okay, we have done this. Better I erase this. So now formula we know a spectacle accommodation equal to a spectacle just in short form, a spectacle accommodation is equal to accommodation. What I can write here, or in short form I'll write, oh my god, the short form I'll write a spectacle accommodation. Okay, is it yes, I indicate a spectacle accommodation, it is equal to VD minus VN, right? So now this is the spectacle plane we have seen. See here. So what will be the Vergence at this point? right? So just see here, what is from this plane to this point, what is the distance? 40 centimeter. As it toward the left side, it should be negative. Okay, distance is negative, and we'll do the reciprocal of this point. What you will get? You will get vergence of light at this point. So Vn equal to 1 by minus 4 minus, it is centimeter, right? I'll do direct 100 by minus 40. It will come at minus 2.5 diopter. So it here in diagram also you can see it is what? Negative divergence light. So that means it is negative light up to how much diopter? When the light strikes at this spectacle plane, you have a diopter of minus 2.5 diopter. Are you getting it? Yes. So Vd is 0. Here the vergence is 0 for when the eyes see. Now according to spectral accommodation, what is happening is, when you are seeing distance, vergence is 0. There is no only parallel ray of light is striking, right? But when you are seeing near at 40 centimeter, 2 minus divergence of 2 point, negative vergence of 2.5 diopter is strike on the glasses. That means change in vergence is how much? 2.5 diopter. That is negative change. That means this negative change, this negative make this light before it is falling here, right, on the retina. So this negative makes this light to fall behind the retina by 2.5 diopter. Understood? So that means there should be some mechanism to nullify this minus 2.5 diopter and make the light to fall on the retina. This is based on spectacle accommodations. Okay, so that mechanism is accommodation. We should have plus 2.5 diopter accommodation, so that the ray will become again nullify, and from the back it will come on the retina. Okay, so this change in vergence, Vd minus Vn, Vd is 0 minus 2.5 diopter. So how much it is? Minus plus 2.5 diopter accommodation is required, or we should do, okay, to nullify this light, and it should get focus on the retina. Am I right? Now say when we are discussing about ocular accommodations, that time we'll see that time we'll see how much changes required. Okay, so this is about Emetrop. Let me continue the same lectures on the ocular accommodations. So in ocular accommodation in Emmetrop, just give the heading as we have completed a spectacle accommodation in Emmetrop, but give new heading as ocular accommodation in Emmetrop, right? So in ocular accommodations, the light for Emmetrop, as there is no glass, it is the imaginary plane, right? Imaginary plane of a spectacle. So the light is still continue to pass parallel up to the ocular plane or principal plane, right? Yes. So here the light is still passing. So same diagram I am using it, okay? But for you have to draw the different diagram for a spectacle accommodation, and now we are going to say about ocular accommodation. So both diagram you need to make separately when you are writing on the exams, right? So this, now see, the parallel ray of light is striking at this plane, principal plane. So vergence of light, how much it will be there? As the parallel from this plane, the distance, so light is coming from infinity, so distance is infinity, right? Distance is infinity, and reciprocal of that distance, if you do, you will get vergence at this plane. So at this planes, at this from principal plane to infinity, distance is infinity, and reciprocal of infinity is 0. So for even for calculating the ocular accommodations at principal plane, it is Vd is vergence at this plane is 0, because parallel ray of light still continue to strike the cornea, right? So vergence at distance is 0. Now you see, for these conditions, when you are wearing glasses, but here also imaginary glass, there is no true glasses because it is Emmetrop. So now we'll say, if it is not true glasses, light will be still continued forward, right? It will be still continued forward. See here, it is still continued forward. So the better diagram, I should make cornea up to here. We have so much megalocornea, I guess. So this is the light is still continue to strike. Right, and at this plane, right, this is the principal plane. Now when this eye is focused for near, when you are reading, when the eye emmetropy is using phone or nearing or focused at 40 centimeter, now then that time we are going to see what is the changes in Vergence. What is the change in Vergence? So see here, we know the distance from here to here is 40 centimeter, and we also know the distance from here to here total, because so many times I have explained this distance up to the principal plane. It is 1.5 centimeter. It is 1.5 centimeter. Right. So now the total distance from object to principal plane is not 40 centimeter. Now it will become 40 plus 1.5. The total distance is now 41.5 centimeter. Am I right? Now if I want to know the Vergence at this point, Vergence of light at this point, now Vn means Vergence of light when the light is focused at near object. So this is 100 by, as this distance is left side, which would be called as negative, minus 41.5, it will be approximately around minus 2.41 diopter. Okay, it will be approximately around minus 2.41 diopter. That means negative Vergence of minus 2.41 is created here. You are getting? So that means if no other mechanism will be there inside the eye, this light will get focus diverged by 2.41 diopter. Are you getting it? Behind the eye. But of course we have a mechanism called accommodation, so lens will accommodate by 2.41 diopter. This is the actual accommodations, because there is change just the in front of the lens. Lens is getting the exact Vergence of light just in front of the eye, and it should know how much to relax and how much to accommodate. So here what will happen now? Minus 2.4 diopter, 41 diopter, it will accommodate. So same things will keep in formula. See, this is the actual concept. Formula they have created, right? So same formula, same things will keep in the form of ocular accommodation OA equal to VD minus VN, and here what we are going to say is VD is 0 minus 2.41 diopter, so it will become minus plus, so plus 2.41 diopter. Ideally, when you are emmetrope and when you are seeing at 40 centimeter from your spectacle plane, when you are seeing 40 centimeter from a spectacle plane, once you are seeing 40 centimeter, you are not accommodating by 2.5 diopter, you are accommodating by only 2.41 diopter. That's the reason they will tell you will accommodate less than the required. It's not like less than the required, because the ideal calculation is only this one. We have to the anatomy will run from this cycle, because lens is we are calculating the Vergence just in front of the lens, right? So I think this is the real one. Okay, and this is our calculation purpose. So once you know the spectacle versus ocular accommodations, what you know, ocular accommodation in emmetrope is slightly lesser than the spectacle accommodations. Are you getting it? Yeah. Now we'll go same thing for the myopia as well as for hypermetropia. So let's discuss first about myopia, and then we'll go for hypermetropia. See, this topic is so earlier I was so confused about this topic, but once I got get into it, it becomes again, I feel same thing I'll tell, it becomes more interesting and it's very easy to understand, and this will provide us a clear concept about accommodation. So now we see about myopia, spectacle and ocular accommodation in myopia. And at last we are going to conclude. So when you are you should remember the value what is there for accommodations, because that is required again. Okay, so here we are going to make one eye. This eye is focused for distance, and here also we are going to see about the eye which is focused for near object, and both are myopic eye, both are myopic eye, but this myopia is corrected with a glasses now. See, last in Emmetropic we have made imaginary, but here it is true. This is the true spectacle plane. Ideally here it should match, but okay, fine. So here also this is -10. This is, assume this is glass, okay, assume this is glasses. So light coming, let's this myopia is how much? +10 diopter. Earlier I told +10 is easy for us to do the calculation. So here let's see, this is how much? +10 diopter. So light coming from distance, what kind of light? Parallel ray of light. Once it come, what will happen here? It will diverge, here also it will diverge, but it will get focus as a virtual image here, right? And of course this should be the far point of the eye, and this, if it is +10 diopter, sorry, it should be minus, man, this should be -10. So if this is -10, if this is -10, then the secondary focal length will be how much? Toward left side, and it should be 10 centimeter. -10 means it should be 10 centimeter, right? 10 centimeter. And of course we are going to see only about ocular accommodations, spectacle versus ocular accommodations, and yeah, so we have to calculate here. So first we'll discuss about a spectacle accommodation in myopia. I guess I have not explained in the earlier things. So first, a spectacle accommodation in what? A spectacle accommodation in myopia. So just you take the when you are seeing distance, this and we are taking the measurement from here, right? You are seeing, when you are wearing glasses, you are seeing distance, right? So for vergence of light which is coming from the distance and a strike here at the spectral plane, so Vd equal to vergence of light at distance, when the eye focus at distance, when the parallel ray of light is striking, so 1/infinity is 0. Now when you are seeing for near object, let's assume 40 centimeter from this here. How much centimeter? 40 centimeter. Erase this. Later we'll see what can be done. So don't confuse with this concept. So we are only discussing now the spectacle accommodation. Later we'll go for ocular accommodations. So here Vn, if this is the near object at 40 centimeter, let's assume this is object point. So the vergence of light, this is 40 centimeter. Already I have told the eye is focused for 40 centimeter from the glasses. So when the vergence of light is striking here, we have did the calculation that this is the plane we are calculating the vergence. So how much distance this is? 40 centimeter. Left side it is negative, so vergence of light will be focused near at 40 centimeter will be 100 by -40. You will get it -2.5 diopter. So that means a spectacle accommodation will there is change in -2.5 diopter. right? 0 and minus 2.5 light will get diverge. Okay, so accommodation they will do is minus 2.5 because change is minus 2.5. So spectacle accommodation equal to Vd minus Vn. So how much it is? 0 minus 2.5 diopter. So you will get plus 2.5 diopter accommodation. But this is a similar purpose. This arises because you are taking measurement from the spectacle plane. I told you once you wear the glass, it's become challenging to measure from the lateral bone. So you are measuring from the spectacle bone. But just imagine you got. So this is about spectacle accommodation. Now just imagine you got some chance or some way to measure from the lateral bone. That means you are measuring from the ocular plane or principal plane, and that is the actual accommodation again, and that is the actual accommodation of the person. So this is not the real accommodation. For 10 diopter myopia, for seeing at 40 centimeter, they will not accommodate 2.5 diopter. They will accommodate something else. So that we are going to see here. So here, okay. So here I'll make now you people make a different diagram, both same diagram for ocular accommodation in myopia. This already I have discussed for spectacle accommodation in myopia. Make a different diagram, give the title ocular accommodation in myopia, right? So when you are dealing with the ocular accommodation in myopia, see light coming from infinity, it strikes here, it strikes on the lens, and once it strikes on the lens, this light will be get focused backward after divergence. So this light will be get focused backward, and this assumes this is 10 centimeter. Now see here, this is 10 centimeter now, and yeah, and once this is act as the virtual object for this eye. Now this focal point or far point acts as a virtual object for this eye. So now we are imagining at this plane, we need to find out the Vergence at this plane, right, up to here. So that means we should note the distance between this point up to this, right? So this total distance we need to know. Do the distance reciprocal, you will do the Vergence, you will get the Vergence of light at this point when the eye is seeing far. See, understand this once more. It's worth to repeat. When you are seeing far, parallel ray of light strikes the lens, and the light diverges, real light diverges, and you will get a virtual image on the far point of the eye. And this virtual object acts as a this virtual image acts as a virtual object for the eye, and it's assumed that light is moving in this way now from the object, from this object. How we have considered this is a real object, light is moving divergent way. So similarly, the light is assumed to move like this, and at this plane we need to find the Vergence. So get the total distance, do the reciprocal, you will get Vergence of light at this point. But this will become when the eye is seeing far. Ultimately, the lights are coming from the far. Are you getting it? Yes. So now here what we can do is, so at this plane, now see at this plane, the total distance we need to find out. This is 10 centimeter and this is 1.5 centimeter. So total distance will be 11.5 centimeter. So total distance will be 11.5 centimeters. So now see here, the total distance is how much? 11.5 centimeter. Actually, these all things what I am talking, you need to write in the form of word, each line, so that it will that is the way like how we will write in exams. But once you are understanding the concept, yeah, it's fine. So 11.5 centimeter, and what will be the Vergence of light at distance when the light is focused on the distance? So this is at this plane, Vergence of light at principal plane. So this is 100 by this, as this distance is toward left side, it should be negative, minus 11.5 centimeter. So approximately you will get right minus 8.70 diopter. Minus 8.70 diopter. So let me write here. Here the Vergence of light when their light is seeing far, it is minus 8.70 diopter. Now the same eye wearing minus 10 diopter lens, okay, wearing minus 10 diopter lens is focused for 40 centimeter. It's focused for 40 centimeter. Now you see what you can do. See, when the light is focused for 40 centimeter, that means when the light reach up to this spectacle plane, how much Vergence it would have? The distance is 40 centimeter. Distance is 40 centimeter. So Vergence of light reaching at this spectacle plane will be minus 2.5 diopter, 100 by 40, and it is left side, so it is divergence light ray, so it minus 2.5 diopter when it is before reaching. So the Vergence of light, I'll write here the Vergence of light just before reaching the lens is how much? Minus 2.50 diopter. Now the Vergence of light, this is very, very, very important to understand. The Vergence of light after emitting the lens is minus 2.50 diopter. Here I can write minus 2.50 diopter plus this is the Vergence of light reaching, and spectacle itself has minus 10 diopter, so minus 10 diopter. So that means total will be minus 12.50 diopter. So once the light will be emerging from this glass, it will become more divergence. They will have more negative Vergence. And once they will be retract backward, their line have been retract backward. Okay, so if this line has been retract backward, then so you have to make a line in such a way that they should meet nicely, right? So here this is the point. Now this is the image, this is the virtual object. This is the virtual object by this two light, created by this two light after emergence. But where is this located? This time it's, see, very be attention here. At this point it is not at 40 centimeter. This is 40 centimeter. At this point it is not, here you are seeing after when they are retracting backward, it is 10 centimeter, but this time it is not at 10 centimeter. How will you find out length? It is just the reciprocal of distance. So now if you want to find out Vergence or power, you will do reciprocal of distance. If you want to find out distance, you will do reciprocal of power. So power and distance are reciprocal, right? So here we know the power is how much? Just after emerging, this has minus 12.5 diopter. What we have seen here, minus 12.5 diopter. Now, so here the Vergence of light is 12.5 minus 12.5. If I do reciprocal of that, I will get some distance where this image is located. So reciprocal of the position of image is how much? 100 by minus 12.50 is equal to, let me get my calculator. So how much we have to do is 100 by 12.5. You will get 8 diopter. Okay, so 8 diopter, sorry, 8 centimeter. So here the light will be this distance from here to now. This lens is how much? 8 centimeter. And here, once the light reaches at this, once you know this distance, then at this point it is 8 plus 1.5. 8 plus 1.5 centimeter. This is from glass to principal plane. So total distance is 9.5 centimeter. Total distance is 9.5 centimeter. Now you see here, and then you do the reciprocal of 9.5, you will get some diopter, right? And that is the Vergence at this point, right? Because from this point to this distance is 9.5. So total Vergence will be approx. Let me calculate how much. 100 by 9.5. So 100 by 9.5, it is 10.52. So 10.52 or 10.5 approximately. So here the Vergence is how much? 10 point minus 10.52 diopter. Here how much? Minus 8.70 diopter. Very useful concept. When you are minus 10 diopter map, when they are seeing for far, it is 8.70 diopter at principal plane, minus 8.70. Same myope, when they are seeing for far, near, when they are focused for near 40 centimeter, the Vergence of light striking is 8.52. So there is change in Vergence, right? So how much change is there? More divergence is there. When you are seeing near, more divergence is there, and this divergence will make light to focus behind the retina. But we have a mechanism called accommodations. So how much accommodation is required? That depends upon how much change is there in the Vergence. How much negative change is there in the Vergence? The accommodation will stimulated. If it is positive change, then accommodation will be relaxed. So we are going to see the changes. So here of course minus has increased. So minus, how much it has increased? So 8.70 minus 10.52, it is 1.82 diopter. It is 1.82 diopter. So change in Vergence is minus 1.82 diopter. Okay, so here first Vn is how much? Vergence of light at, when the light is focused for near, the Vergence of light at principal plane is how much? Vn is minus 10.52 diopter. Okay, so we know about ocular accommodation formula. Ocular accommodation is equal to Vd minus Vn. Vd is how much? Minus 8.70 minus, how much is this one? Vn is minus how much? 10.52 diopter. So this is plus, it will become plus 10.52 minus 8.70. We have seen plus 1.82 diopter. That means what you understood from this all? Spectacle accommodations we have discussed. Again, myopic ocular accommodation we have discussed. So in this, what we have learned is the actual accommodations in myopia when you are wearing glasses is less. Ocular accommodation is 1.82 diopter, and in ocular accommodation in Emetropia we have seen it is 2.41. So that means myope wearing glasses, myope wearing a spectacle will accommodate less as compared to Emetrop. Okay, myope wearing glasses will accommodate less as compared to Emetrop. Emetrop is 2.41 diopter and myope is 1.82 diopter. Okay, so this is the one story from this spectacle versus ocular accommodations. Okay. Now we are going to see about, okay, coming classes will be seeing about spectacle versus ocular accommodations in hypermetropia. Okay, and of course the same concept will be utilized there. So I hope I have cleared about the spectacle versus ocular accommodations in Emmetrop as well as for myop. Okay, so please do like and subscribe my channels if you have feel that this information is useful and informative to you. Thank you.